So just to recap, we did a tidal analysis. We looked at the different constituents and the percentage that they make up, and actually the top 20% of the constituents make up almost 90% of the tide. We calculated the form factor, which is just on the border of semidiurnal, mixed, mainly semidiurnal, and calculated the tidal range. And you'll see this is important because when we pick a diurnal site, then obviously it will use it will use the K1 and O1 rather than just the M2 and S2. Okay, what we're going to do now is predict the tide. So now that we've done the constituents, we can use the other function that's available in UTide, this UTide reconstruct. So you use solve to do a harmonic analysis. Now we're going to do a tidal constituent, a tidal prediction. So again, every function you have outputs in the square brackets, inputs. So here we're going to have just the tide. And here we are going to reconstruct the tide. So first of all, what we need to do is give it the time. We're going to first of all do it for 1996. Now we need to convert that to a datum, because again it only reads datum, not datetime. And then we give it the coefficient function. Okay, so it's easy as that. So actually you can see it predicts the tides incredibly easily. So here we have the tides for 1996 predicted from those constituents. We can, if we want, add other components, which we'll do in a minute, and just predict the tide for certain constituents. Now that we've got the tide, we can work out the surge. So surge is the total water level in 1996 minus the tide in 1996. And that's the surge component. It should be a lot smaller. Okay, so now we can have a figure. Again, let's cut and paste this figure just so we can do this as quickly as possible. Okay, this time we're going to have two subplots. Okay, on the top subplot, so again, I can probably get rid of the xlims. We're going to use the plot function. So here I'm going to plot the time, TS, in 1996, and I'm going to plot the water level in 1996 as blue. And then on top of that, I'm going to plot the tide. So we can see the water level and tide on the same axis, and I'll plot that in red. I'm going to add back in the X label. We didn't need that for the plot above, but here we do. Okay, and then on this plot here, again, we can take this all out. We can add in the X and Y label again. Here, I'm going to plot the surge as green. Okay, and then we're going to run that. You can see this should happen actually very, very quick. So there's the total water level for a year. You can see just the tidal component. And then here's the storm surge. So that's actually probably a big hurricane. And if you Google it, I think you will find a hurricane at the end of July 1996. You can see a storm surge of up to 1 meter. Okay, what we're going to do now is do the tidal prediction again, but rather than the data, if we go back to TS, the data only goes up to the end of 1997, but actually I want to know the tides for, let's say, for example, a field trip in 2023. Okay, so what I'm going to do say is date time, 2023, January the 1st, 0 months, 0 hours, minutes, and here I'm going to go at intervals of minutes. Now the data is in hours, but actually I want now it in minutes. The nice thing about a tidal prediction is you don't have to, you can have a completely different time period and a completely different frequency. So we're going to go from hours to minutes, and here I'm going to go to the 31st of January 2300. I'm just going to prime it to turn it into a column. Again, there's no function called time, so I spelt it wrong, date time. And in fact, it would fix it for me automatically there if I wanted to. Okay, so now I'm going to go up and nick the reconstruct code. I'm going to put that in here. So now I'm going to reconstruct the tide for the year 2023 for the time that I've just specified in 23, but using the tidal constituents that I calculated in 1996. And you can see it works very, very quickly here. Okay, so now that's the predicted tide. And again, we can do a plot of that quite quickly. I'm just going to have one subplot, and I'm just going to plot the... I always try and keep my colours consistent, so every time I plot the tide it's always red. I've left all the same title. So there's your tide. So you can see you can predict a tide for a period that you don't have before. Okay, and then finally what I'm going to do is I'm going to predict the tide. But this time, I'm going to call this 1. This time I'm not going to use all of the constituents. I'm just going to use, so there's an extra you can put on the end here. I'm just going to use the M2 constituent. And then I'm going to repeat that. I'm going to call this 2. But this time I'm going to do, because it's more than 1, I need to put in these funny special brackets. But this time I'm just going to include S2 as well. M2 and S2. And then for the third one, I'm going to run it again, but now I'm going to pick all of the main 4, so K1 and O1. So we can run that and do those various predictions. Now we can go back up here and cut and paste this code for a figure. Now on the top one, I'm now going to replace this with 1. I'm going to set a xlim just to make it look nice. Date, time, 2023 11000, and here I'll put to the end. We went to the 31st, 23. Okay, now I'm going to, what should I call? I'm going to actually change the title. I'm just going to put M2 here. Okay, now what I'm going to do is cut and paste that again, but this time I'm going to put M2 plus S2, and this will be number 2. So I want 3 plots, and then this time I'm going to do it again, but it's going to be M2 plus S2 plus K1 plus O1, and this is now number 3. So you can see once you get going, it's actually very, very fast. Oh, I did that the wrong way around. Should be month 1, day 31. So it's the year, month, day. So you can see it's very easy to make a mistake, but it's very easy to correct it as well. So here you can see the M2 is just perfect. Once you add the S2, you get a nice spring-Newton cycle. Once you add the diurnal constituents, you start to get diurnal inequality and one spring-Newton cycle being slightly higher than the other ones. Okay, so what we can do now is we can download data from other sites. So I'm going to go to Blackboard because for some reason, unfortunately, this isn't working. And I'm just going to download the data for the other sites. We'll go to Practicals, Practical4, and let's download these data for this other sites. So there's 5 other sites. So far we've just looked at China, but now we're going to bring in some sites along the coast of Vietnam because the tide actually changes quite dramatically here. Okay, so here are my other data sets. I don't quite know why it's added the 1 on the end, so I'm just going to take that off, rename them. Or you could just change the file name. Okay, so here are some other sites. Okay, so let's look at this Vung Tang site. So in China, this was semi-diurnal. The tidal range was, and I'm going to, yeah, so now we can just go up to SID here and change this to 381. So we can run this all again. It might be a little bit slow. Just the only slow bit is the, is where you do. So here, remember, we had data from 1954 to 1997. So here you'll see it'll probably be a different period. So yeah, now the data is available a different period. There's big missing gaps. We've done the harmonic analysis here. So again, it'll be interesting to look at the constituents. And here, actually, you can see that M2 and S2 are not the largest. Now, K1 and O1 are the largest. So this site is definitely going to be diurnal. So here you can see the last one was 0.26. This is now 2.49, which is very close to diurnal. So it's mixed, mainly diurnal. The tidal range is a lot smaller. And now you can see actually the data. There's quite a strong seasonal cycle in there. And you can see that it kind of varies. Now the spring nuclear cycle is much bigger. And actually is probably not as important as K1 and O1. Okay, now what I'm going to do is something really clever. I don't want to have to run this 5 times. So what I'm going to do is I'm going to switch off this clear, switch off the SID, and instead I'm going to define a function. And I'm going to have the name as an output, the latitude, longitude, the form factor, the tidal range, and the input is the SID. Now, I've already written this for you, but what you can do is download the practicaltides.site. And essentially what I do now is I call this 5 times. Practical tide, I've called it template here. So probably actually you could either add template on the end, or you can just take out the word template, but I'm just going to add it here. So I'm going to run this, and now what it does is in one code it's going to run everything 5 times. It will take a little while, and then what it's going to do is going to produce a nice figure now, and this is what I want you to do in your assignments. So in your assignment I want you to do things across multiple sites. So you can see here how I've calling this live script from another live script, but running it now 5 times. Now I could turn this into a loop and actually run it for 100 sites if I wanted to. It's very, very easy to do. It will take a little bit of a while because it's doing that for all of the sites, and you can see it produces all of the figures in there. But actually what I'm really interested in is this bottom figure. Okay, so it's saying there's a problem. Now what is the problem? Practical tide template 636. So there is a 636 there. So just trying to work out what the problem is. So it says TR is not assigned. So let's go back here and work this out. So I'm going to switch off the function here. So again, if anything goes wrong, now obviously I wasn't expecting that to go wrong, but we can just run this and work out why that went wrong. And this is what's part of MATLAB, is really kind of understanding what that is. So H651 seems to all be working right. Again, we have only a limited amount of data here, and in fact no data. So we can start to try and work out what is going wrong here. Okay, so it's got a form factor. Oh, so you can see I've made a mistake here. It should be tidal range, and actually I could tell that when you come back here because it said TR not assigned. So you can see making it a simple error there. But again, you don't need to panic. You've just worked through this systematically, looking at the red, and you can work it out. So it's always good to make mistakes. So let's go back here, and we'll have to run that all again. So it will take a few minutes, but we can be patient. And hopefully now it should work. And this, as I said before, is really what I want you to do in your assignments. Okay, so you can see we're getting on to 651 now. It seems to be running fine. All of the individual figures will save there, but what I'm really keen is to now look at figures across sites. And you can see that each time I run it, I'm putting it into a different row. So this fifth one is the data's going into row 5 of the different variables. Okay, so you can see it's running through all of the sites. So this is just a much better way of rather than running each one manually. And this is what I want you to do in your assignment. Okay, so I think it's just running the final site. Okay, now it's going to load in coastlines and it's going to nice produce. So this is what I want you to do in your assignment, is really compare between sites. So now that we have the data stored, we can do this scatter plot. We can use the scatter function and we can plot the form factor. So now we have our 5 sites. So you can see this is almost semi-diurnal. Here we go into very strongly diurnal, go into mixed, mainly diurnal, and then back to semi-diurnal. You can see the tidal range is bigger on the Chinese coast, but it decreases as we go. And we've exported the data as a table, so we can see the site name, China, going then into Vietnam, the longitude, latitude. So you can see the form, we go from semi-diurnal to diurnal, mixed, mainly diurnal, mixed, mainly semi-diurnal. And you can see the tidal range goes from 4 meters up to 5 to 2 to 1.5 back down to 2. So this is what you can do, and you can actually go through and reproduce this now for all of your sites. You could have you could turn it into a function. Just remember to switch off the clear and the SID, because then you define those as input variables. But you could essentially do this for the mean sea level one and the Santee one as well.